If you are new to the channel, then subscribe the channel and press the bell icon for further notification. So okay students, welcome you all in lecture 1 of this new series, GATE Engineering Math Differential Equation series. So today I have taken, for the first class of this series, I have taken 3 questions on first order differential equation mostly, and 1 second order differential equation. Okay, then let's start. So in question number 1 it is mentioned to calculate this differential equation is given, and to calculate xt at t tends to infinity. So for solving differential equation, I always prefer, if it is a simple differential equation, and then it is better to go to the Laplace transform theory. And for electrical engineers, you have already Laplace transform for complex number, for signal systems, for even for electronics also. These are important phenomena, so you have to know Laplace theorem. So it's better if you go through the Laplace theorem. For simple equation, it becomes a differential equation, it becomes very easy and handy. So we will try to explore the differential equation properties, how we write it, and explore that differential equation property in Laplace. So I will take Laplace of this one. So Laplace of double dash always starts with x square, s square, xs minus this square, then it will reduce to 1, and you will start with the initial condition, that is 0. Actually properly 0 minus it is. You take care of it, is actually 0 minus, and then minus, it will continue minus, then next is s to the power 0, then it will be x dash 0 minus, actually 0 minus. If 0 minus is not there, then you put 0, whatever 0, but actually it is 0 minus, plus 3 into what will be for single dash, it will be s xs, because s1, next x0, x0. So for cube it will be x cube, then s square, then s1, then for s0 it will be x double dash. So you can feel it, it's easy. Once you write first one, then the rest becomes very easy. And Laplace of 1 is 1 by s. So if you put all the constant, I think they have given no constants are given. So if you take x's one side, so if you take common x's, then it is s square plus 3s plus 2, s square plus 3s plus 2 is equal to, suppose this is k1, this is k2. So what you will write, k1s plus k2, this constant suppose because nothing is given, and then plus this is also I have taken k1, so it will be minus 3k plus 3k1, and then it is 5 by s. So what is your xs? Xs is this divided by this, k1s plus k2 plus 3k1 5 by s divided by s square plus 3s plus 2. So no need to simplify this one, because they have asked you to find at t equal to infinity. At t equal to infinity, how we calculate initial value theorem? In Laplace it is, if it is t tends to infinity, in Laplace it is limit s tends to 0, s into xs. Suppose it is t xt, you need to calculate xt where t tends to infinity, then you do this one. So here it becomes easy. If you multiply with s, so what it will be, limit s tends to 0, if you multiply it will be k1s square k2s plus 3k1s plus 5, because ss will get cancelled, this is s, divided by s square plus 3s plus 2. Now it's, you see, it becomes very easy. If you put s, everything will be 0 except 5 by 2. So 5 by 2 is the answer. So if you see simple differential equation, you can try with Laplace. Differential equations which having other variables, you will see, in that case we will use normal differential equation formulas, but for simple differential equation it's better if you go to Laplace. Then what is the solution? So you can take Laplace, as I was mentioning. Laplace, if you do, that will be very helpful for your other subjects also, especially for electricals. So if you, next time I will not write xs, capital X means you assume that it is, because writing is not so important here. So this condition is given small x0, so it implies your capital X is equal to x0 by s plus 3. Now you can take Laplace inverse. If you take Laplace inverse, then it is x2. In Laplace it is capital, in time domain it is small x. So it will be x0 e to the power minus 3. So this is the answer. 3. Now they have asked you to find trapezoidal rule. We will see trapezoidal rule in numerical methods if questions are there. But in differential equation we are not going to that. So they are not seeing whether you are doing trapezoidal rule or not. Just you need to, what you need to solve it. That's it. So for solution, whatever solution you do, that will be okay for you. So for solution, what you can do, you can apply anything. So it is, if we apply Laplace here, it will be Sx minus x0 is equal to 1 by s plus 2, because e to the power minus 2t is 1 by s plus 2. x0 I think they have given, x0 is that is 0 minus, which is 0. So your x will be 1 by s into s plus 2. Now how to do is partial fraction, you know, I think if you don't know the partial fraction, I am explaining for first time, I will not repeat it. Suppose 1 by s into s plus 2, you can write it a by s plus b by s plus 2. Now how to easily calculate ab? There is a shortcut, you can apply this one. To calculate a, numerator, whatever numerator it will come here, 1, and denominator it is s, so s we will not put, you will remove s. So what is left? S plus 2, other factors excluding that s, and the denominator what is there, that is equal to 0. Whatever denominator you will put 0. So a is equal to half. What will be b? Again numerator 1 will be there. What is in the below of b? Denominator s plus 2, so we will not write s plus 2, so what is left? S. And for s plus 2 what we will do? We will put s plus 2 equal to 0, that means s equal to minus 2 will put, so minus half. So it will be half, if you take common, it will be 1 by s minus 1 by s plus 2. Now if you take, this is original, so if you take the time domain, if you take Laplace inverse, then it will be half 1 minus e to the power minus 2t. So what they asked you to find at t equal to 0.01. So if we apply here xt, so it will be half 1 minus e to the power minus 2 into 0.01. If you solve it in calculator, you will get it 0.0099. That is your option C. That's all for today. We will continue in next class. If you liked the video, then press the like button and please give your valuable comments in the comment section.